Given a car going at 20 meters per second that then accelerates constantly at 3 meters per second squared, how far has it traveled after 4 seconds, assuming it maintained its acceleration? Maybe I don't need a picture for this, but I'm going to still sketch one because I like to encourage everyone to draw pictures here. And I don't always draw very good cars, so especially on here, I'm just going to draw some like whatever. There's sort of a car right there. And we know that it's saying it's going at 20 meters per second, but then it says that word like that then accelerates constantly. So I'm going to interpret this as a initial speed or initial velocity. So maybe the way I'd like to look at this is to say v naught is equal to 20 meters per second. That then accelerates constantly at 3 meters per second squared. So this car is also accelerating. I mean, when I draw an arrow here and I say, okay, that's the direction of its acceleration, since it's clearly speeding up, it's in the same direction, it's kind of supporting its speeding up. That's at least how I'm interpreting that, but I'm going to draw that in my picture there as a 3 meters per second squared with those units. It's obvious enough to me that that's an acceleration, but maybe what I'll write down here is a is equal to 3 meters per second squared. And you might note, like, if you think to yourself, like, well, maybe I'll just do this and not bother with the picture. That's probably okay for a problem like this. But then it's saying how far has it traveled after 4 seconds, assuming it maintained its acceleration. So we're maybe describing a process with this initial speed, this acceleration, that has a duration of 4 seconds. So in all the kinematic formulas, when we see t, that's meant to describe the duration of the process that you're going to describe by that formula. Now it's saying how far. How do we think about that question? Well, one way to look at this is to say, like, if it started at some initial position, say x naught, right, and then sometime later it's at some position x, it's the difference between those two. But another way perhaps that I could look at this is I could say, when I'm talking about this distance here, maybe that could be adequately symbolized by delta x. And one of the ways that you can write the first kinematic formula is simply delta x is equal to v naught t plus 1/2 a t squared. And so if I go and say, okay, that's actually the question. How far has it traveled? Delta x equals the question mark, therefore. And I've got this formula, and I've got v naught, I've got a, I've got t. You know what? I think I can just start to plug into this. So maybe this is actually a really straightforward question. Just plug into the first kinematic formula. And since this is physics class, I'm going to track all the units to make sure I don't make a mistake somewhere here. And maybe if you're looking along with me, you can make sure I'm not making a mistake. So that was acceleration there. Common mistake that I've sometimes made, and you might find yourself doing as well, is to write this and say everything's fine and forget to put the exponent there, but the units will clue you in, right? Because this should be, we're solving for delta x. I should be getting units of meters for each term individually here. Now I can go ahead and put this into my calculator. It's probably not that hard to do without the right, because 20 times 4 is 80, and then what is this here, right? So this is like, I don't know, there's like a 4 squared is 16, right? But then half of that would be 8, and times 3 would be 24. 24 plus 80, I think, is 104. Okay, that's the numbers there. I guess I didn't need my calculator. But check out the units, meters per second times second meters. Checking this one as well. This is the one where if I might have come up with a different number if I hadn't squared this, but the units I would have recognized, wait a minute, there'd still be a meters per second there. That can't work. So it's good that I'm checking that, because that's, again, a common mistake that I make. A lot of people make that kind of a mistake. So checking units is a really good way to catch those kind of things, and we can see this answer is correct.